Donald Knuth has set up his estate so that this software will be used in perpetuity long after his death. It is perhaps the most bug-free software that has ever been created. It's that powerful. And thanks to increases in computing power that happened back in the 90s, we can now run this on an ordinary laptop computer. You can do LaTeX processing on your phone, for heaven's sake. But just think about that. It was invented in 1978, where the only way you could run it was on a mainframe. My, how the technology has changed. So, unless there are any questions, shall we dig in? Okay. Now, the first problem we have to overcome is, how do we get the software? Well, you can download the software, and I'll show you the websites where you can get all of this stuff later. But in an academic environment, we all know that we don't always have control over our computers. And we also know that it's sometimes difficult to instruct students who have never used a computer before on how to set up a Unix-based workflow. So we're going to eliminate that problem entirely by using an online portal called Overleaf. And I am now going to share my screen. Let's see if this works. Allow Zoom. Okay, hang on. I have to allow Zoom permission to access my screen. Okay. Okay, so it says I have to restart Zoom, and I really don't want to do that. I fell into the same trouble that Chris did. It looks like they have updated Zoom. Let's see if I can get this to work. Can you all see my screen? Okay, yes. There we go. All right. So let me get that. Zoom app would like to record this computer screen and audio. I'm going to deny that because I'm not recording this, am I?
We're recording.
You're recording. Okay, so I'm going to deny that. All right. So we are going to go to overleaf.com. And so this is a portal. It's actually based in England. And what this is an online server system with a complete tech and LaTeX installation that runs in your browser. Okay, so if you haven't already done so, please log in to your Overleaf account. And when you do, and by the way, the accounts that we're going to be using are all free. So Overleaf makes their money off of selling subscriptions for high-end features like multi-author collaboration and things. That's their business model, but you don't need any of that to set up a free account here. Okay, and you can log in, I think, with your Google credentials if you wish. It will accept several other types of credentials. And by the way, if you have questions, please ask. And if I miss them in chat, if someone will just say, hey, there's a question in the chat, I will stop and address them. Okay. When you log in to Overleaf, you will see something that looks similar to this. This is your project dashboard, is what they call it. And you can see that I have numerous projects here. My guess is you probably don't have this many projects sitting there. So I would like for you to, over here on the left, click on that button called New Project. And we're going to create a new project, and we're going to call it Intro to LaTeX.
Joe?
Yes.
Could you make your screen larger, or the window larger?
Make the window larger? You mean?
Like, can you full screen it?
Oh, full screen it.
Yeah.
Like that?
That would be great. Thank you.
Okay.
Thank you.
All right. Everything okay so far? Now, when you create a LaTeX document, it is nothing more than a plain ASCII text file. So in principle, if you have the LaTeX software installed on your system, you don't need anything else. This is not a word processor, and that's a huge thing. I want you right now to snap your fingers and erase everything you know about word processors from your memory, because what I have found is that people tend to approach LaTeX like word processors, and you can't do that. There are no menus in LaTeX. In fact, LaTeX is designed to be used from a command line terminal. But
Joe,
yes.
sorry to interrupt. There's a question from Larry.
Yes.
Which choice should people pick when they choose a new project?
Oh, that's a good question. Let's see what the projects are here. Okay, so you've got a blank project. And when you do that, I'm just going to give it a name here. Now, I have one called Intro to LaTeX, so I'm going to call mine another Intro to LaTeX. And you create that, and it will create a new project, and it will by default create a document called main.tech. Okay, and here's what we're going to do. First of all, we're going to click on those three little dots there, and we're going to rename this. Now, what you call it really isn't important. I'm going to call it intro.tech. And then I'm going to come over here and I'm going to zap the contents of that, because like I said, we are going to start from the very beginning. So erase all that scary LaTeX code that you see there. And the next thing we need to do is a one-time setup. Okay, so we need to come up here and we need to click on this menu button. And when we do that, this little menu is going to slide in from the left. And we need to set some things for our workflow. So the first thing we need to set is we need to tell Overleaf which compiler we're going to use. There are several different compilers or engines that we can use to process our document. Eric says, is there a link to Overleaf I should go to? Overleaf.com should get you there. If that doesn't work, just let me know. Okay, now, some of these tools date back to the 1980s, but we want to use the modern workflow. So here's what I'm going to ask you to do. Where it says compiler, I want you to click on the little selection button there, and I want you to choose the one called LaTeX. Lua is the Portuguese word for moon, but it is also the name of a very powerful and very apparently commonly used scripting language called Lua. And LaTeX is a LaTeX engine or compiler. I will frequently use those terms interchangeably, that allows you to embed Lua code in your document and process it. We are not going to do that, okay? So don't, but here's the big reason we're going to use this particular engine. This particular engine makes using Unicode characters trivial. If you speak a language other than English, you may have letters in your alphabet that have diacritical marks and accents on them. The old 8-bit LaTeX compiler cannot support such characters because they weren't in existence when that software was created. Nowadays, all modern computer keyboards can enter all kinds of non-English characters. We can enter any of the characters from the various Asiatic languages. We can enter Cyrillic characters. We can enter characters with accents. We can enter different alphabets. We can enter emojis, all kinds of things. This compiler will not complain when we use such characters. Now, one area where this is helpful is in mathematical notation. On your keyboard, the menu button, Rumi, is up at the top. If you go into your project, if you go into your sample project, it's right up here at the top, in the very top left-hand corner of the Overleaf screen there.
Well, there is something like, let's say, apple with the leaf, and then a house, image of the house. Which one is it?
It's the one on the left, the image with the leaf.
Okay.
And the menu should just slide in from the left.
Okay, thank you.
Okay. So we're going to use the LaTeX compiler. And you probably aren't aware of this, but LaTeX is actively developed. There is a large distribution that is issued every year, usually in March. And here's one downside to using Overleaf, and that is they only update once a year, and they usually do so several months after Tech Live has been released for that year. So we're going to have to use the Tech Live 2022 distribution. I'll say more later about what all that means, but for right now, the rule of thumb is always set this to the most recent version of Tech Live. If you look here, you can see that they have Tech Live distributions going all the way back to 2014. If you have a large library of publications that you don't want to risk losing, you can actually install different year versions of the entire tech ecosystem and maintain that library on your computer. We aren't going to need to do that though. So we're going to set this for the most recent distribution that is available. And in this case, it is Tech Live 2022. Every project must have a main document. And so right here, you want to set your main document to be intro.tech. It should be able to detect that automatically and set the main document to intro.tech for you. If you rename your main document, it should still stay as the main document. Okay, you can now we're going to configure the editor that we're going to use here. We haven't started using LaTeX yet. So I'm going to set my default language to English. And there are numerous languages here that we can choose from. Unfortunately, I speak English, so I could probably get by in French. Larry, if you click on those little vertical dots next to the file that your project created, you can rename it, and you can rename it to intro.tech. The name really isn't important. What is important is that .tex extension. That is important. You can, the first part can basically be whatever, anything you want, but I chose to call it intro.tech for today's purposes. Now, there's lots and lots and lots of other editor features. Pardon? I thought someone asked something. There are lots of editor features that we can configure here. You can turn on autocomplete. You can set it so that it will automatically close your braces and parentheses for you. You can choose the editor theme. You can choose your font size. I'm going to bump up my font size a little larger there so everybody will see it. You can choose the font that your editor uses. This is not the font for your document. This is simply the font for the text editor that we're going to be using. And there is a built-in PDF viewer that we are going to use. So set the PDF viewer for Overleaf. Now you can come back and change these settings here anytime you want to. It's a one-time thing and they will stick across all of your projects. If you come down to the bottom of this setup menu, you can click on Show Hotkeys, and this will pull up all of the keyboard shortcuts that Overleaf knows about. I'll be honest with you, I very seldom use these, but some people find them very helpful. And if you want documentation on the Overleaf system, you can click the appropriate button at the bottom down there. And Overleaf has an extensive library of LaTeX tutorials. And near the end of the workshop, I'm going to give you a half a dozen or so websites with information and about LaTeX itself. But one of those wonderful resources is Overleaf itself. They have a very extensive library here. And Overleaf has very good customer service. They will generally respond to your requests, typically within a couple of hours. They have advisors, and in the interest of disclosure, I am an Overleaf advisor. I get no compensation for that, but if people have questions about Overleaf, they can ask me. You can click on Contact Us, and you can send a message. And somewhere around the planet, someone is monitoring this stuff 24/7, and someone will generally get back to you within a couple of hours. Okay, also notice up here at the top, there is a word count feature. You can copy your project, and you can download your project as either a zip file or a PDF file. I'll show you more about how those things work later. Okay, any questions about this setup menu? Like I said, this is a one-time thing, so we shouldn't have to do this again. Everything good so far? Because now we're about to write some LaTeX code. Okay, excellent. Okay, so if you just click anywhere over in the right-hand field here, that will dismiss that menu. And by the way, let me just show you this. Clicking on the little house will take you back out to your dashboard. And then you can select the project that you want to go back into. So I'm going to go into the one that I called Intro to LaTeX. And let's see, I need to make sure that I have the, okay, that's all set. See how those settings stuck there? I went from one project to another, and all of these editor settings stuck. By the way, this editor is open source, so you can install this on your own computer if you want to. Okay, now let's dig in with some actual LaTeX code. It is obligatory that when you learn a new programming language, you must do the Hello World program, okay? So here's what I want you to do. We're going to take this line by line here. In fact, I'm going to zap those. On line 1, I want you to type \document class and then put the word article in curly braces. And I'm going to tell you exactly what this line of code does. First of all LaTeX commands /must begin with a \. There are no exceptions. Second, there is a concept called a document class that defines all of the stylistic parameters of your document. It determines your margins. It determines the font size that is used. It determines the font that is used. It determines the layout of the entire document in this one statement. Now, a big concept with LaTeX is you worry about the content, let the document class worry about the formatting. Okay, so we're not going to ask the question, how do I change the margins? Because that concept doesn't exist here. Now, I'm going to cheat a little bit, and I'm going to show you later how to change the margins in a document. But remember, I told you earlier that I want you to forget everything that you know about a word processor. So we're not going to talk about margins or anything like that for the time being. That's all handled when you select a document class. There are 5 default document classes in LaTeX, and I can never remember what they are. One is article, one is letter, one is memoir, one is book, and there's another one whose name I can't remember. Article will get you, oh, Beamer is the other one for creating slide decks and presentations. Article is used for 99.99% of all LaTeX documents. Okay, it will do pretty much everything that you need to do, even for journal submissions. And speaking of journals, if you do, for example, if you have to publish a journal publish a paper in, say, an astronomical journal somewhere, that journal will typically supply you with a document class. Likewise, if you're at a university and you have to write a thesis, or you have a grad student who has to write a thesis or dissertation, that university will typically provide you with a document class to use. Let's see, Eric says, at the top, my computer screen says code editor and visual editor. Not what yours says, source enriched text. I have never seen that before, Eric. You're logged into Overleaf? That is strange.
Wonder if it's the same things, but they just are calling them differently, because I can imagine code editor
That's strange.
being the source editor, which is what we're doing right now.
Okay, as long as everything else looks the same, I say let's proceed. Now, I will tell you that I'm on a Mac too. In fact, I'm on a brand new M1 iMac here, and I'm running this in Safari. I will tell you that I have a professional level account because I'm an advisor. You all probably don't have that. So maybe that's the source of the difference. I wish Paolo were here because he works for Overleaf and he could answer that. I have never seen this difference before, so I don't know, but let's just proceed. And as long as everything works, I'm just going to ignore it. Is that okay? Okay.
Joe, I have another request, because
Yes.
I have a small screen and I can't read the font.
Oh, yeah, you want the font bigger.
Yeah.
Okay. See,
Thank
that's
you.
easy. I can come down here and I can set that to 18. How's that? Is that better?
That is much better. Thank you.
Okay, good. I like lots and lots and lots of screen real estate, so I tend to use very small fonts. So just holler if you want the fonts to be bigger. Okay, so document class article. This must be the first line of every document. Now, we need to actually put something into our document. So we need to open up an environment. And notice that this editor senses that I just entered the first line of a document environment, and it should complete that line for you. Everywhere there is a begin, there must be a corresponding end. There is no exception. Every begin must have a corresponding end, and the name of the environment must be the same. There are no exceptions, ever. Okay. Now, let's create the Hello World program. Just simply type the words Hello World between the begin and end document. And again, this is called a document environment. Anything sandwiched, but anything with a begin and end is called an environment. And so you put content into an environment. Okay, so make your screen look like mine. And then over here on the right, This is where the magic is about to happen here. There is a green button. Yours may say recompile. If you click on the down arrow, I recommend you turn auto compile off, because if you have auto compile set to on, it's going to be grinding away in the background. And I have seen it stop working before. Remember, these are in the UK. These servers are in use all over the world right now. There are people using Overleaf all the time. I typically set my auto compile to off. So if I come over here and click recompile, that little circular thing there will whir for a couple of seconds, and you should then be presented with this. And this pane here is adjustable, by the way. You should be presented with a beautiful PDF file that says, "Hello World." Give me some sort of signal or thumbs up if you got that to work.
Mine doesn't work. It says intro to LaTeX, Nikolova, June 2023, introduction. That's what I have.
Okay, go back to your source window
Uh-huh.
and make sure it looks exactly like mine.
So I have to erase everything from line 5 down.
Well, there shouldn't be anything after the end document.
There is nothing after end document, but on line 4, I have title, intro to LaTeX, 5 /author, Nikolova, 6/date, 8.
Okay, okay. Erase all of that content. Get rid of all that. Yep.
Okay.
Yep.
Uh,
And make it look exactly like mine. Nothing more, nothing less. When you create a new project, Overleaf will fill your intro project or your default file with some boilerplate stuff. And I want you to zap that. You'll get used to seeing, you will recognize that after today's workshop, but we're going to get rid of all that stuff, and we're just going to use these 4 lines of code right here are all you need at the moment. Okay. And let me know, Rumi, if that works.
okay.
Chris says she's using her document to take notes. This will change the way physics students take notes in class because they can use mathematical notation. They can use the same mathematical notation that you use on the chalkboard or whiteboard to take their notes. Think about that. And it will look just like it will look in their textbook. Congratulations, you just wrote your first LaTeX document. And if you listen very carefully, the universe did not come to an end. And this is a PDF file. If you click this little icon here, you can immediately download that PDF file to your computer. Go ahead and click that document, that button right there. And on a Mac, it should deposit your PDF file in your downloads folder. I haven't spoken Windows since 2002, so I don't know where Windows sticks things nowadays, but go to wherever you look for your default downloads and your document should be there. It should be called intro.pdf. And this is a PDF file that you can do whatever, you can email it to your instructor or your dean. You can do whatever you want to with it. Now, later on, I'll show you how to use the share feature, and you can send your instructor a link to your document, and the instructor can see the source code and the PDF simultaneously. How's that for a great debugging workflow? And by the way, this all works splendidly on an iPad as well. Did that work for you, Rumi?
No, it did not.
It did not.
No, it still have the same thing.
Okay, can I
and
ask you to share your screen?
Yeah, absolutely.
Okay, let me stop sharing. Okay, share your screen so I can see what's happening here.
Okay, let me, I lost everything, so hold on for a second. Okay, how do I share my screen with you?
At the bottom,
Yeah.
there should be a toolbar along the bottom of your
Yes,
Zoom
yes,
window,
I saw it, I saw it.
and there should be a button there. There you go.
Do you see it?
Okay, let's see here. Okay, get rid of use package graphics.
Okay.
You're getting advanced on us here. We don't need that. Get rid of line 2. There you go. And eliminate the space
Yeah.
before the word document in line 3. That really shouldn't matter, but it bothers my OCD. Now hit recompile.
Oh, wait a minute, what is recompile?
Over there on the right. Hit that big green recompile button.
Sorry, I don't see it.
Nope. The green button that says recompile.
At the top. Now go to the right.
Okay, I don't see it here.
Where's your cursor? Okay, go down slightly.
Oh, it is hiding behind.
Oh, do you have something else open?
Yes, so this one, okay, now when I move this one, now I see the green button over here.
Okay, there we go. See, we can't see the other stuff on your screen. Now, I'm going to tell you later how to read the error messages, okay? This is the hardest part about using the LaTeX, is understanding the error messages, okay? And we're going to talk about that later because I'm going to show you I'm going to ask you to do some things that are going to generate errors, and I'm going to show you how to read the error message. Congratulations, Rumi, you did it.
Thank
You
you.
just wrote your first LaTeX document. Woohoo! All right, excellent. So let's see. We have a question over in the chat here area. I'm going to be a PhD student in education. Do you think I really need this? If you're going to do any publishing in any STEM discipline, yes. This is canon in publishing in STEM disciplines. I even did my poster, as Chris said, for the upcoming Sacramento AAPT meeting. I did my poster in LaTeX, and I actually sent it to the printer day before yesterday. Woohoo! So I would argue that it's an alternative. It's becoming more and more heavily used in the humanities. I know it's used in linguistics. In fact, there's a LaTeX developer here in the States. His name is Alan Munn at MSU. He uses LaTeX extensively in his academic publishing. So even if you're not going to publish in STEM disciplines, you can use it in the humanities. And like I say, from now on, all of my posters are going to be created with LaTeX. It's just so much easier to deal with. You can use the Beamer document class to do slide decks. The last 2 NCS AAPT meetings I've gone to, I've done my presentations in LaTeX. And if you ask me at the end of today's session, I'll show those to you. I won't show you how I made them because each of those subjects is worth a workshop all to itself. Okay. And let's see, I have another question here. Adobe Acrobat could not open because it's either not a supported file or because the file is damaged. I don't use Adobe products since PDF is built into the operating system of Mac. I will say that I've never seen that particular error before. Are you on Windows or a Mac, Floyd?
Mac.
See if preview will open it.
Yeah, okay. I'm switching to preview.
I'll be honest with you, since it's been about 20 years since I last used Adobe Acrobat Reader. So I would say if it works in preview, it's
Preview can't
probably,
open it either.
That's strange. I've never seen that.
All right, I'll recompile. But carry on.
Well, let's see. Mine opens. I'm running Ventura. And there's nothing strange about these PDF files. They should be PDF standard. There is a standard for the PDF
Okay.
document format. These should.
It opens now.
Okay.
No.
Lens.
All right.
And like I said, it's becoming more and more popular in the humanities. But I think the ease with which you can create posters, I think, is going to make this very, very appealing. In fact, Chris and I were talking about doing a workshop just on posters and maybe using LaTeX to do that with. Okay, let me go back to my screen here. And I should pull up my browser. There we go. Okay. Are we ready to proceed? Okay, let's make our document a little more interesting here. Let's do this. Let's say this is my first. Now watch what I do here. /LaTeX document. Okay, now I'm throwing another command at you here. And notice that I'm following it with a pair of empty braces. Okay, so add that little bit of code there and recompile your document. And make yours look exactly like mine, because I introduced a workshop. I introduced an error. Chris corrected the error for me in the chat, but I introduced an error in my source code. And here's how I know I have an error. Over there on the right-hand side above my PDF document, I have a red 1 staring at me, okay, in that little red box there. I'm going to click on that. And this is called the log. Every time you compile a LaTeX document, there is a log file that is generated. The problem with correcting errors is that sometimes reading these log files is a bit of an adventure, okay? And they're sometimes very hard to parse, and you have to go through them manually on most systems. But one thing I really love about Overleaf is it parses out the most important part of the error message. Look at my screen here, L.4. That tells me I have an error on line 4 of my source file. And then it proceeds to tell me on the next line here what the error is. It says the control sequence at the end of the top line was never defined. Okay, that basically means something is misspelled, most probably. And notice that I have a lowercase x there. To correct that, I need an uppercase X. So here's the new lesson. LaTeX commands are case sensitive. You have to be very careful with that. And by the way, these are really called control sequences. I frequently use control sequence and command interchangeably. And for our purposes, they are interchangeable. So I'm going to change the lowercase x to a capital X, and then I'm going to recompile. And this time I'm going to get a clean build. And notice what happened there. Oh, look at that. I generated the LaTeX logo. Now here's what I want you to do. I want you to take out the empty braces, and I want you to compile your document, and I want you to tell me what those empty braces do. I want you to see what happens when you take them out and recompile your document. You should see something in your PDF file. I won't do mine yet because I want to give everyone a chance to try this. Yep. Okay. So sometimes if the command that you're using is something that needs to be typeset, sometimes we'll need to add a space after it. And in this case, the way you do that is you use empty braces. You can also use a backslash like this. Okay, and that will work. And that's actually an escaped white space. Okay. And if I recompile this, it's going to give me the same look in my PDF file. But a lot of people prefer to use the empty braces like that. So that's why I did that. Okay, but this is how you get that fancy LaTeX logo in your document. It's just another command that is defined internally, and this is how you do it. Now, you probably, in a formal scientific publication, don't need to wow your audience with showing the LaTeX logo. So let me show you some basics about how to manipulate text. So I'm going to erase this line. Okay. So this is a normal sentence in the default font. So why don't you put a sentence there? It doesn't have to be this exact same sentence. This is just the sentence that I chose to use. We're going to, whatever sentence you choose to write here, we're going to copy and paste it many times over for what we're going to do next. But just put a sentence there. And if you want, you can hit recompile. There should be no surprises here. Oh, one thing I do want you to do is I want you to intentionally misspell a word. I'm going to misspell the word sentence, and I'm going to really butcher it there. Okay, and I'm going to recompile my document. And notice that my document still compiles. LaTeX will not correct your spelling. But notice that the editor does realize that in the English language, sentence is not a word. Okay, but I just want to emphasize that LaTeX itself will not catch spelling errors. It doesn't know how things are spelled. It knows how commands are spelled. In other words, if it sees a backslash, it knows whether the thing coming next is a correctly spelled command or not, but it doesn't know English from French, from Chinese, from whatever. Okay, so it will not correct your spelling. It will not correct your grammar. You, as the author, must take care of those things. And this is one reason why using a nice text editor is handy. But remember, your document is just an ASCII file. You can create your document in Notepad on Windows, or in TextEdit if you're on a Mac, or in Pico if you're on a Linux system. It's just an ASCII encoded text file, nothing more. Okay, does that make sense?
Yes.
Okay. Everybody got a clean compile here? Now, I promise we're going to make these documents much more fancier, but like I said, we're building up one step at a time. Okay, now the default font is called computer modern. It was invented in 1978 by Don Knuth. He invented it for publishing his lifelong work, The Art of Computer Programming. And this is the default font for your document. Now, I will show you later on how to change the default font. I'm not going to show you how to do that just yet. Okay? But this is what ordinary text looks like. Now, here's what I want you to do next. I want you to highlight the sentence that you just typed, and I want you to copy it. And on a Mac, that is Command C. And I'm going to paste it at the end. But I'm going to do something a little different this time with this sentence. Watch what I do here. I'm going to say I'm going to say left brace /BF series, and then I'm going to close that with another brace at the end of that sentence. Okay. So basically, I'm going to surround that sentence in curly braces, and I'm going to add BF series at the beginning. Now, would anyone care to take a guess as what this might do when we recompile this?
Does it bold?
BF stands for boldface. That's exactly right. So if you recompile your document, you will see the same sentence twice, but the second time it will be in boldface. Okay, so the BF stands for boldface. And notice that I include that whole sequence there in curly braces. So I'm going to change the text here to say this sentence should be in boldface, and then I'm going to get rid of this other stuff here. Okay, so this is how you make text boldface. Now, notice that we did this for an entire sentence. What if you only want one word to be bold-faced? So here's what I'm going to do. I'm going to say this time I want, now watch what I do here. Text BF, one word to be boldface. Okay. Now, when you compile this, you're going to see the word one in boldface. But notice that I used a bit of a shortcut here. Okay. So when you're manipulating text, there are generally two types of commands that you can use for altering the appearance of that text. One of them is an explicit command that takes as an argument the text you want to be affected. And it doesn't have to be one word. It can be two words, or indeed you can put an entire sentence inside the curly braces and it will look the same. This first way of doing it acts more as a switch, and it lasts for the duration of the scope defined by those curly braces. Okay, curly braces are important in LaTeX just like they are in C or Java or C++ code. They define a scope over which some change takes place. So, for example, I'm going to take out this. Now watch what I do here. I'm going to take out that curly brace and this curly brace, and I claim that everything after BF series will now be bolded. just like that. Okay. So think this is sort of like a switch, and you turn that switch on and off by using these curly braces like that. Now, that third sentence is outside of the scope of those braces, so it's not affected by the BF series. Does that make sense? Okay. Eric says crystal clear. Excellent. Now, from when
Nancy
it
has
comes,
a question.
yes, yes.
How come, what's the difference between /BF series and /text BF? If you can use more than one word for text BF, why bother using series?
That's a good question. The simple answer is, well, I don't know how simple it is. For every change that you want to do with text, like bold or italic or sans serif, the designers, and ultimately LaTeX was invented by a computer scientist named Leslie Lamport. He's still active. He doesn't do any LaTeX development anymore, but he wanted a dedicated command that takes as the argument the specific thing that you want to change, in this case, boldface. He also wanted a corresponding switch that stays on until you turn it off. So think of BF series as a light switch. When you turn that switch on, it will stay on until you turn it off, either with a closing brace. Now I'm going to show you something that I had not intended to show you, but since Beverly asked, I'm going to go there. Watch what happens when I don't use the curly braces there. Let me get rid of this. Okay, so that whole line, or those last two sentences, those are all boldface, because that BF series switch, I turned it on, but I never turned it off. Now watch how I turn it off. Here's how I turn it off. I use / normal font, and that will give me this. Okay. Now notice I don't need curly braces for this light switch analogy. Okay. However, normal font is another command that you have to remember. So the preferred way of using this switch version of boldface is to enclose the switch and the text that you want to boldface in curly braces. And this brace right here says, I'm about to turn on a switch. And there I turn the switch on. This ending brace here says, I'm clicking the switch back off. The /BF tells you that this is a text mode command. I want a boldface, but I only want to boldface what's inside the braces. They have the exact same effect, Beverly. There is no different. You can't look at the compiled document and tell which was used. Every programming language has certain stylistic conventions, and this is one of those situations. For every text manipulation command, there is a corresponding switch. That's the whole story. It's just two different ways of accomplishing the same thing. Does that make sense?
Yes, thank you.
Okay. And I confess that I have started using the switch mode more often, just for no good reason. Like I said, you can't look at the end document and tell which way it was done because the effect is the same. But if I want to boldface a whole sentence or a whole paragraph, I tend to use the switch because I can turn that switch on at the beginning of the paragraph and I can turn that switch off at the end of the paragraph. It's like turning on a light switch when you come into a room and then turning off that switch when you walk out of that room. The text BF is more like a traditional command for doing it. There's no turning off or turning on. It's just a slightly different way of thinking about accomplishing the same thing. Okay, so let me recompile this to make it match my code here. Okay, everything good so far? Okay, y'all, this is as hard as it's going to get for manipulating text. This is as difficult as it's going to get. Oh, let's start a new paragraph. Okay, I want you to hit return twice. Now notice that I have a blank line there. The way you tell LaTeX to start a new paragraph is to insert a blank line in your source code. I'm going to recompile. And you can see that over there on the right, I now have a new paragraph. And notice that it indented automatically for you. Now I'm going to make this, I'm going to make this paragraph longer. And what I'm going to do is I'm just going to write a sentence. It says, this is another sentence in this paragraph. And I'm going to copy and paste that sentence in, 2 or 3 times here. I'll do 3 of them. Okay. So just grab a sentence. It doesn't matter which one. And copy and paste that into your paragraph. And when you recompile, now you can see the effect of the indentation. Okay. So the way you start a paragraph is you put a blank line in your source code. You can put 2 blank lines and your end document will look the same. You can put 100 blank lines there and your document will look the same. It only looks for 1 blank line to signal the start of a new paragraph. So I just like to put 1. You will eventually develop your own style of writing this code. And so my style is, I just want 1 blank line there. What if you want to skip a line between paragraphs? Aha!
Mhm.
Okay. You're going to drag me there. Okay. In general, if the document class doesn't do it, you should not want to do it. Okay. But of course, there is a way to do it, and I'll show you how to do it. However, it is discouraged. Why? Because that is considered a formatting issue, not a content issue. Now you may say, well, wait a minute. What if I want to offset some text from a paragraph? That is a typographic concept, and there is a way to do that cleanly in LaTeX. Okay. I will show you how to do it, but you've got to promise me that you will never use this. The way you do it is you, at the end of the first paragraph, you say \V space, and then you give it, I'm going to say 1 centimeter. It understands inches, meters, millimeters, and points. Okay. And if you recompile, it will do it. However, the LaTeX developers will tell you that you must not do this because it interferes with the document class. The idea here is that you should not tell LaTeX how to format your document. Line number 1 tells LaTeX everything it should need to know about formatting your document. So I'm going to get rid of this and I'm going to pretend I never showed that to you.
So Joe, that means we have to learn how to define a new document class if we want things like only one space after a sentence and a line between paragraphs instead of indenting.
That is the hard way to do it. You can do that. The easy way is to, you can, okay, everything I'm showing you can be overridden, okay? LaTeX is a Turing complete programming language. Anything that you can do in any other language, you can do in this language. It's just not easy. Everything can be overridden. It is, and here's another thing that's kind of strange about LaTeX. Every reserved word can be defined and redefined multiple times, and the compiler won't warn you that you're doing that. So in the process of overriding all of these formatting defaults, you could literally break your document to the point to where it won't compile, and LaTeX can't help you anymore. So if you want, like, for example, in a future workshop, when I show you how students write up their solutions, in fact, I'll show you a hint of this when we talk about mathematical notation. There are clear and cleanly defined typographical ways of doing these things when they make sense. For example, if you want to insert a verse of poetry, believe it or not, there is a LaTeX command for doing that. If you want to insert a block of computer code, there is a LaTeX command for doing that. That doesn't interfere with the defaults set up by the document class. So in certain specific situations, like a PhD thesis, yes, Chris, you can and absolutely sometimes must define your own document class. And that is something very difficult to do. And as John points out, it is very analogous to writing cascading style sheets in HTML. That's a very good analogy. If you don't know what cascading style sheets are, don't worry. But in modern 20 years old HTML code, the appearance of a website is specified in something called a style sheet, and you simply use the HTML tags to insert your content and to format your content. So yes, that is a valid analogy, John. Did I answer your question, Chris?
Only kind of, because
Okay.
I really want a space between paragraphs.
Okay.
It helps me read. So
There is a way to do it that doesn't interfere with the document class. What you would do, the easiest way is to use the VSpace, and then specify how much you want, maybe 5 millimeters. Okay. This is the least dangerous way of doing it. And it didn't work in that case because I put the, did I use VSkip or VSpace before?
I thought it was VSpace.
Okay, I thought so. Well, let me just test that. Let's make it 2 centimeters. But now I will warn you, if you go online and ask the LaTeX developers about this, they will question your life decisions when you start saying, I want to put 2 centimeters of blank space between. Well, why do you want to do that? Why would you possibly want that? Because they're thinking in terms of typography, not necessarily word processing and formatting of the document. They're thinking typographically, why would you want to do this? And they're going to say, well, if LaTeX doesn't do it by default, you probably have no typographical reason for doing it. They have made me cry over things like this. When I
So-
showed them some code that I spent 2 years of my life on, I walked out of the chat room crying. Okay.
So I
These are
think
vicious people.
that's a problem because, one of the real reasons that I think that is important to say use a sans serif font and to have a lot more white space between paragraphs is readability and accessibility.
Yes,
right?
yes,
So
yes. And there are packages out there that address those issues. And when you look at the final document, you can't look at this PDF file and reconstruct the LaTeX code that produced it. It's just a PDF file. So if you see a need to do things like this, you can do them. And no one will know the difference from your document. But they're depending on what the need is. Like I haven't shown you how to do sans serif font yet. I'll show you that next. And I'll show you how to vary the text size as well. There are ways to do all of these things. The hard part is knowing that those ways exist, and that involves consulting the LaTeX documentation, and that is problematic because it's spread out over it. It doesn't exist all in one spot in the LaTeX ecosystem. Each piece of the LaTeX ecosystem has its own documentation. And so you may have to sort through 5 pieces of documentation to figure out how to do 1 or 2 things. And that's a huge problem. That's a huge problem.
So Nancy also wants
Yes.
bullet points and such.
Yes, I will show you how to do that. It is on my list.
Okay.
It is absolutely, positively trivial. In
let's-
fact, let's do that right now. Okay, so I will show you how to do lists, and I will show you how to do, Chris, remind me to show how to do sans serif. Okay, so let's start a new paragraph. Okay. And there are 2 ways to do lists. We can do enumerated lists, or we can do bullet points. You say bullet points there, so that's the one I'll show you first. Now watch what I do here. We're going to open a new environment. And this environment is called itemize. Every begin must have an end. There are no exceptions. Okay. What do you put inside an itemized environment? Why, you put items. And by the way, I keyboard very, very fast. So feel free to tell me to slow the hell down if you want me to. So make your source code look like this. The indentation is optional, but I like it because it helps you organize your thoughts. And notice that this looks kind of like something you might write in a traditional programming language. It looks kind of like something you might write in Python or perhaps C++. Okay. And when you compile this, Nancy, this is what you get. Notice it chose the default bullet for you. You can make that bullet anything you want it to be. But here's the best part. Watch what I do here. I'm going to take this third thing and I'm going to move it up here to the top of the list. Now, obviously, that's going to change the order. Okay, so that was to be expected. Let me show you why this is very cool. Let's change itemize to enumerate. Now, what do you think this is going to do? This is going to replace the bullets with numbers. And again, You can change these to letters, A, B, C, D, if you want to. You can put them in parentheses if you want to. But watch what I do here. I'm going to change the order over here in my source, and they will automatically update over here in the compiled document. Notice that this is not 1, this is not 2, this is not 3. This is just the first item that the compiler sees in this environment. So in other words, you don't have to worry about the numbers because LaTeX tracks those numbers for you. So the difference between enumerate and itemize is that enumerate uses numbers, itemize uses bullets. And that's how easy it is to get lists. And they can be of any length whatsoever. Piece of cake. Was everybody able to get that to work?
For me, it didn't have any numbers or bullet points.
Okay, if you want numbers, instead of itemize, you say enumerate.
Yes, I put numerate, but it didn't work.
I'm sorry?
I put numerate, but it didn't work. I copied everything exactly as it is, and there is nothing. Can I share it my
Yes,
screen?
yes. If you get an error, please share them, because I tell my students errors are how you learn. And that's true in this situation as well. Okay,
that's
so
what I
let's
got.
see. Let me look at your code. Oh, I see what the problem is. You don't have an end enumerate. So come down to the end of line 14. Hit enter. And now do an end enumerate. Now that's still gonna throw an error because you need enumerate instead of numerate. You need to put an E at the beginning of numerate. There you go. And you need to do that in line 11 as well. Now I'm going to ask you to take line 15. Now your document will compile now. Okay.
Yeah, I see the numbers now.
And it says you've got an error there. So let's do this. Click on that little red thing up there.
Here?
Next to the compile button. Let's read that error message. Yes, click that. Let's see. You've closed more groups than you opened. You have an extra curly brace in line 5. Do you see it?
Over here?
That's it.
I think it needs to go the other way, doesn't it? Oh, there it is.
Now your document will compile cleanly. Ta-da.
Oh, yeah.
Now, I'm going to ask you to do one more thing, Rumi. Go down to line 15 and put the cursor at the beginning of that line and hit backspace so that the end and the begin are in the same column. Hit backspace. Do it again. And one more time. There you go. You see how that sets off your list?
Yeah.
Begin and the end. The begin and the end. Your document's going to look exactly the same.
Okay.
LaTeX doesn't care about white space except when it does. Okay. And within the code block there, it really doesn't care where the white space is, but I like to format these things so that I can immediately tell, oh, there's the beginning of my list, there's the end of it, and there are all the items in between. So this is a style thing, and you'll get more comfortable with this as you do more of this. Okay, let me bring my screen back. Everything going, see how easy this is? I told you all this would be so simple. And I haven't heard anyone complain yet. Okay, I promised I would show how to do sans serif, okay? And I'll show you I'll show you italics as well. So let's take a sentence here. I'll take this one right here. And I want to make it sans serif, okay? Now it turns out that again, there are two ways to do this. We're going to use the switch way first. We're going to say, we're going to open up a curly brace and we're going to say \SF family. And then we're going to put a space. And then I'm going to close that switch with a brace right there. Now, when you're talking about fonts in LaTeX, you can talk about the family, the typeface, the size of the font. There are lots of terms that come from typography. And I'll be honest, I don't understand the origin of a lot of these things, but sans serif is a font family. So when you compile this, everything within this scope right here will be sans serif in the current font. In other words, computer modern with sans serif. In order for this to work, the font that you're using in your document must have a sans serif version. If it doesn't, then using this command will have no effect. Okay, but with the default font, that's not a problem. So that's how you do it. The short command for doing it, I'll do it on this word right here, is you say text SF. And you simply use curly braces. There is a pattern to this. All the text formatting commands, they begin with a \text. That's easy for me to remember. I don't always remember this family and series stuff, but I can remember text SF and I can remember text SF. So that's how you do sans serif. Anybody care to guess how you might do italic?
You just have to type italic.
Almost.
Yeah.
Let's see. John says text IF. That's very close. That is very close. You would say text IT. And that will typeset that in italics. If you want to use the switch version, you would simply say now this is weird. This is IT shape. Italic is a shape. Okay, and yes, the editor in Overleaf is very intelligent. Most text editors will work this way on Windows and Mac. They are smart enough to know what it thinks you might be trying to do, and it will do that. When I'm not working on Overleaf, just on my Macs, I use an editor called TechShop, and it's very intelligent. It does the same thing, but they have put a lot of effort into this editing environment here, and it is sometimes it's smarter than I am, and that really pisses me off. But it's a very well-designed editing environment. Okay. So you can say either text IT or IT shape. Okay. And speaking of italics, let me show, I need to show you one more thing here. And that is how you emphasize one word. Okay. So I'm going to take the word sentence right here, and I'm going to preface it with \EMPH. That stands for emphasis. Now, when I compile this, by default, that's going to show up as italic. So you may wonder, what's the difference between this and using italics? Well, here's the difference. In different document classes, emphasizing a word may typeset it in bold instead of italic. It may typeset it in all caps. You can actually go in and you can program what the emphasis command does. You can make it do anything you want. Remember, everything is variable in this language. But by default, in the typographic mindset, when you want to emphasize a word, you simply say emphasize, and you let the document class decide how to emphasize it. So another way of saying this is that you should try to think of these commands in a semantic way. In other words, if you want to emphasize a word, just tell the document class, emphasize this word, and let the document class do the work for you. In other words, you shouldn't have to tell the document class that I want to emphasize this in italics. Let the document class, let the style sheet, if you will, handle that for you. Think semantically. And you'll see this when I show you how I use this in my physics classes. If I want students to type a momentum, I defined a command called \momentum, and all they have to do is feed it a number, and it typesets the number with the correct unit. So the student doesn't have to worry about all that. All they have to worry about is the concept of momentum. Okay, that's what we mean by semantic markup. You think about what you want to do and tell the document class, I want to emphasize this word, and you let the document class decide whether that means italic or bold-faced or whatever. Now, you can override all of this, but it is generally not recommended, at least not for beginners. Oh, and let me show you another important difference. Well, Chris, there's evidence that this approach actually helps them learn the units, because they will recognize, oh, that thing doesn't have the right units. That they will learn the units. At least I can say that it doesn't hinder them from learning the units. But remember, in the homework, a lot of times we get frustrated with students when they leave off their units. Well, this way completely eliminates that problem, because if they remember the name of the quantity, their document, when compiled, will automatically provide the units, and that will actually help the students remember them.
That makes sense. Never mind.
There's a lot of psychology. I'm deviously psychological in my approach to this.
Are we going to have a break, Joe?
Do you want a break? Let me show you one more thing here, and we'll take a quick break here. Another benefit of using these switches is that you can stack them. Whoops. Suppose you want bold italic. Well, there's no command for bold italic. I'm sorry, bold sans serif. But you can stack the SF family switch and the BF series switch. And when you compile your document, you will get bold sans serif. You cannot stack these other commands. It simply will not work. If it does work, it is by accident. It is not designed to work. So that, whoever asked about, I think it was Beverly, asked about the differences between these switches and these other commands. That's another very important difference. You can stack the switches. You can't stack the individual commands with the curly braces. Does that make sense? Okay, so here's what you should be able to do at this point. You should be able to show different paragraphs. You should be able to emphasize words or sentences. You know how to change the typeface to make boldface. You know how to change the shape to make it italic. and you know how to invoke sans serif, and you know how to do lists. That's 60, 75% of a lot of things that you will need to do. So we can take a short break here, and when we come back, I'll show you how to vary the text size. That is absolutely trivial. And then I will show you how to do mathematics. And that's where it gets really, really, really fun. And as a matter of fact, during the break, grab a calculus book or a physics book if you happen to have one near. If you don't, that's fine too. But if you have a physics or a calculus textbook nearby, grab it and bring that back with you from the break.
Sounds good. Should we meet back in, say, 10 minutes?
Fine with me.
Perfect. So at 1:45.
Okay. You're going to love the equations, Floyd. You're absolutely going to love it.
By the way, Joe, it's Nancy, not Beverly. Beverly's my
sorry.
last name.
I got the surname and the first name mixed up. Apologies.
No problem. I go by both, so it doesn't matter at all.
I have secretly done the same thing with Floyd James before. So Rumi, is this meeting your expectations? She might not be there.
Yes, actually, it does. I'm still having some problems with one of the text.
Okay.
Let me
You
share.
want to
this.
share your screen?
Yes.
Okay.
Oh, wait a minute. Where is mine? Here. So for some reason, at some point I got lost here.
Okay. Let me see what it says
so-
here. Text BF1 S. Oh, I see the problem.
Okay.
You have an extra L in family.
Oh,
Now
Okay.
it'll compile. Boom.
okay. Thank you so much. I cannot copy that fast. I'm just trying to type in and I don't see, actually, I don't check the spelling. But it was very helpful. Thank you so much. I have to write a portfolio and I actually did it, and on Word doesn't work very nice, and numbering of the pages, I always have to go back, and if I insert a document, I have to renumber everything and reference to that point or the other points. I was thinking that probably using Overleaf is going to be better. It's going to look better, and it's going to do this automatically, basically.
LaTeX, once you understand the basics, LaTeX will handle all of that stuff flawlessly.
Yeah. Is there a book?
There are.
No.
I'm going to show everybody. I've got a stack of books here on my desk that I'm going to show everybody at the end.
Okay, perfect. Thank you.
Yep. So once again, we had more registrants than actually folks who showed up.
Yeah, we have about 12 who've shown up. One left because she was an education major, but yeah,
Oh, did that person leave?
yes.
Bummer. I got to where I did all of my tests and exams with LaTeX. The book, the Astro book that I wrote, I did in LaTeX. Everything that I gave students, I did in LaTeX.
Well, it's like most things. Once you get used to it, then there's no reason to do something else.
Our departmental secretary actually started using LaTeX for writing tests and exams for the math department. But she didn't learn raw LaTeX. There was a commercial product called EXP back in the 90s. And our department bought a site license for it. And she learned to use that. So she was actually using LaTeX, and the math people were saying, oh, LaTeX is too hard. But she was using LaTeX to generate her documents for the math faculty. I thought that was just ironic. So far, Word is in front.
I'm sorry, say that again.
Floyd typed over in the chat there. So far, Word is in front. With text-based stuff, yeah. I mean, you know, you highlight it in Word and you click italics and whatever, bold or whatever. The math stuff really is gonna separate the word processors from the typesetters.
That is for sure.
And this was all invented for mathematical typesetting anyway, because Don Knuth was dissatisfied with the typesetting processes for mathematical content in the late 1970s. And so he actually took a year off of his regular work. I think he had already retired by then. He took a year off and wrote the TeX processing language. And he updated that in 1980. And then I think in 1980, it was either 81 or 82, Leslie Lamport created LaTeX, which is a bunch of macros that sits on top of TeX. And the software has LaTeX has only changed one time since then, and that was in 1992. And this software has been steadily used ever since. So if you have I have documents now that that are 20 years old and they still compile flawlessly. The developers take great pains to make sure that if a document compiles correctly at one time, it will always compile correctly without any user changes. They have just done an extraordinary job at making that happen. Yeah, there are third-party products for conventional word processors that pretend to take your mathematical input and output it into LaTeX. Maple will do it. Mathematica will do it. Maxima will do it. All the standard computer algebra systems will generate LaTeX output. But sometimes, yeah, they don't get something quite right. And LaTeX evolves, it is developed. And so sometimes there may have to be a change to the LaTeX kernel that these other products don't catch. And so they may not update. And so that might cause them to break. Anytime you're converting from a LaTeX document, which again is just a plain ASCII text document, to a Word file, and Word files are basically XML documents, which I guess you could argue are also ASCII text files. But Microsoft changes things. I mean, I don't know of any two versions of Word that were identical in terms of their, you know, where's this in the menu and all of this stuff. And so, yeah, it's pretty easy to break when you go from a word processing mentality to a typesetting processing mentality. Although there are tools that can do it, I don't use them because when I see a document or an equation, I immediately picture the LaTeX code in my mind.
Yeah, what about math type, using math type to cheat and then export it?
Lots of people do that.
Oh.
And 99% of the time it works fine.
Hmm.
The times when it probably doesn't work is if you have defined your own custom commands. And I'm not going to show how to do that, but you can define, like if you, for example, if you, let's say you define a macro to typeset Gauss's law for an electric field in integral form. LaTeX doesn't know that, or excuse me, math type doesn't know that. So if you use the command Gauss's law, that math type is going to choke on that because it doesn't know what that is. It's not a standard LaTeX command.
Well, how long did it take you to be so good that you're faster without doing something like that? You just do direct.
I wrote my first book in the 90s using the older version of LaTeX 209. So I've been using LaTeX since approximately 1992 or 1993. And I've just used it consistently since then. And I've just developed a sense for it, I suppose. It's like, you know, if you see, if it's like saying, okay, I need to do this, I have this algorithm. Some people can say, oh, I can envision how to do that in Java or in C++. Same thing. I think about it, I guess, from a computational point of view. I think of it as a macro language, which is what it really is. And so I've just developed a skill for it, I guess, after 2 decades of use. 3 decades now, I guess, of use.
Can I share the
Yeah.
story, Joe?
Yeah, sure.
This is Chris. I had never used LaTeX and I'm a terrible programmer. I hate coding. And I learned LaTeX to write my thesis because I watched other people try to do it in Word and they would change something and then it would have to repaginate for 3 hours. And then a decade later, I hadn't touched LaTeX in all of that time, and I was able to write formula sheets for my students without a whole lot of learning curve, I guess, relearning. So, and you know, it's been another 15 years, and now I'm relearning LaTeX, but it's coming back, and Overleaf has really changed things.
Overleaf has been a game changer because now you don't have to. I used to do all of this and I would have to go around and install this on 15 computers in my lab. And every time, you know, and I would have to do that every March. And IT, they cussed about it, but they let me do it. They didn't like it, but they let me do it. And then the big problem hit when students said, okay, how can I put this on my computer at home? They had a hard enough time installing Windows applications, but you know, installing something on a Linux box or on a Mac in those days, it was very, 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 very difficult for students to do. And Overleaf actually didn't used to be called Overleaf. It used to be called ShareLaTeX.com. And a couple of entities merged to form Overleaf. Johnny Hammersley, the founder of Overleaf, is actually a PhD physicist. And so Overleaf, like the World Wide Web, was an online tool designed by a physicist primarily for STEM folks. But thanks to Overleaf, LaTeX has now widened its scope and it's used a lot in the humanities. A lot of journals across the whole publishing space use LaTeX. Almost all STEM textbooks are done with LaTeX. I tell students, if you take any math course, there's a 90-some% probability that textbook was produced in LaTeX. Matter and interactions. I've got the source code for matter and interactions right here on my computer. The third and fourth editions were all done in LaTeX. And I'm proud to say I had a role in convincing the authors to switch to LaTeX once they saw the utility of it. They had been using Adobe InDesign. Does that sound right? They had been using various Adobe tools for doing it. And when I showed them LaTeX, they're like, wow, this is great. So
Shall we back to things?
I'm sorry.
Shall we get back?
Sure,
to
if you want.
lessons?
I'm ready. I'm going to, first of all, does anybody have any questions? Is everything working for you?
It took a while to find my errors. I was getting a lot of like errors, and it's a little hard to interpret like what exactly is wrong.
Yep.
But I think it's all kind of like typo things, having a space where there shouldn't be, having the bracket not quite right. So
Yep. Yep.
now I know it's just look for these little things. But at
Yep.
first it can be daunting.
The two most common sources of errors are misspelled commands and misplaced curly braces. And as Chris pointed out, the editor knows all of the built-in LaTeX commands. So if you start typing a command, it will try to complete your thought by choosing the command that it thinks you want and making you, and to select the one, you simply hit the tab key. You can experiment with that in the editing environment. That will cut down on misspelling of commands. And then with curly braces, if you have a line of code where there's either an opening or a curly brace missing, you should see a little triangular yellow warning sign over on the left side of the editing window. In fact, you can experiment with that and generate an error. Let me share my screen here. Let me go back to sharing my screen here. And I'll put this back in. There we go. Okay, so for example, if I leave off this curly brace here, you see how that throws a warning sign? And I haven't even compiled anything. And if you hover over that, it'll tell you that it's, hey, you've got an unclosed group, which is LaTeX way of saying you're missing a curly brace. This is a very intelligent editor. And like I said, the editor is open source. You can download it and install it. I've never done that, but that part of the Overleaf system is open source, and you can actually install that if you want to. Okay, I want to show you two more things. I want to show you how to change the size of the text. So I'm going to start over here. Okay, so there's a single sentence written in the default font and the default size. The default size, by the way, is 10 point. If you want to change that to 12 point, I'm going to show you how to do that. Look up at line 1. And what you do is you put 12 point in square braces immediately in front of the document class. And what that will do is that will tell LaTeX that you want that in 12 point. You can use 10, 11, or 12. Not all font sizes are defined by every document class. Remember, the document class controls the formatting of your document. So for example, if you put 32 in here, I don't think that's going to work. It should bomb. And see, you get a warning saying, oh, that font doesn't exist. Okay. So I can make that 11 point font. That should work just fine. There's 11 point. But the square braces here are the way you specify an option. Okay, and the default option is 10 point size. So now, how do you make this text bigger? Well, watch how I do this. Let's suppose I want to make this large. You open up curly braces, and inside the curly braces, you say \large. And when you compile, ta-da, you get large. What if you want it even larger? Well, if you want it larger, you use all caps. And you get this. What if you want it larger? Any guesses?
/ginormous. No.
You're close. Huge. Okay, and notice that this doesn't generate any errors. This is the typographic way of doing it. Now, if you try to use huge with all caps, that will not work. That should throw an error because that size doesn't exist, you see. Now, just for comparison, I'm going to revert to the original size like this. Okay, now let's go the opposite direction. What if we want to make the text smaller? How do you think we do it? Think logically.
Small
Say again?
/small.
Yep. It's just that simple. What if we want it smaller?
Capital small.
Good guess. No.
Smaller.
Nope. Starts with a T.
Tiny.
Tiny. And there are a couple of others here that are not necessarily obvious. There is a footnote size. So if you do footnotes in your document, this is the size that they will be presented. Typeset. Now I see there's an error there. Let's see what that says. Footnote size. Oh, do you see my error?
Footnote instead of foot.
I misspelled footnote. I need a T right there. And now I can recompile. And there it is. Okay. Now, again, some of these sizes are defined in the document class relative to the size of the default font. So in different document classes, large with all caps may generate different size letters. Does that make sense? It's all the document class determines how large is for a given document written with a given default font. Okay, and I haven't shown you how to change fonts or anything like that. And remember, everything can be overridden, but you risk breaking the entire universe if you do that.
Can you do like superscripts? And I'm not talking about for mathematical entities, but in text, if you want to refer to it, an
Yes.
article down the bottom, usually, one of the
Yes.
ways is to put a superscript with the numbers. Is that kind of automated in some way?
Yes. I think it's text superscript. Don't hold me to that. I don't do this very often, so I'm not going to guarantee that this is going to work. Let's just see. And it did. Okay. Now, if you want to do a footnote, this is not how you do it. If you want to do a footnote, and I had not planned to talk about this, but if you want to do a footnote, you say / footnote, and you put your footnote in curly braces. And when you typeset this, it creates the index for you. I didn't place it quite right there. That's my fault. And then down at the bottom, it puts the footnote for you. But you don't use superscripting to flag your footnotes. Now, I plan another workshop on how to do references and things like that. And that includes footnotes. So let's see, I guess I need to put the period there instead of there. That should make that look better. There we go. That's how you do footnotes, for example. Ta-da, and there it is at the bottom. It draws that line and everything for you. Okay. Are you ready to do some mathematics? Okay, well, that was a ringing okay, Floyd's ready. All right, let's do some mathematics. All right. All right. Now, there are two ways to do mathematics. You can do inline math and you can do display math, okay? Inline math is when you want to incorporate mathematics into a sentence. So let's see, Einstein said E equals MC squared. Now, look at what I did there. I said / left parenthesis. And then here I said / right parenthesis. And in between, I typed my mathematical stuff. You can probably guess what the caret does. It's how you get an exponent. So if you compile this, two things happen. First of all, the letters are set in italic. That's because you're in, I'm going to answer that, Larry. I'm going to answer that. You took the bait. I'm going to address that. So when you go into math mode, LaTeX says, okay, this is not text. I'm going to typeset this as mathematics. And it, by default, it uses italics for that. The braces there, the open left parenthesis, I'm sorry, / left parenthesis, / right parenthesis, that is how you show inline math mode. And you can extend that over more than one line. For example, you can do, I don't know how this is going to work, equals M, C, C. You see how that broke? You see how my editor wrapped that line there? That is of no consequence to LaTeX. Notice that it ignores the white space. It puts the correct pleasing amount of white space around the equal sign. So you can break this along different lines if you need to. You typically use inline math mode for very short mathematical expressions, or you could say Pythagoras, if I can spell here, tells us that, let's see, what is A squared plus B squared equal, I would never teach the Pythagorean theorem this way, but just for demonstration purposes, Okay, and you can probably guess how that's gonna do. Oh, I used a C there instead of a 2, so let me fix that. What if we want to use Greek letters? What if we want to use alpha instead of A? Well, that's simple. You just say \alpha. And if you want this to be beta, you say \beta. And we'll make that gamma. Let's make it delta. Okay. When you compile, it does exactly what you think it's going to do. Now, if you try to use alpha outside of math mode, so for example, let's do this. Okay, now watch what happens when I do this. Notice I didn't surround that with math delimiters. This is going to throw an error. Oh, well, that's surprising. I did not expect that to work. But look over here. It says alpha must be inside math mode. That should not work.
It's become Microsoft. It knows what you want better than you do.
Oh my God. I'll be very honest. I did not expect that to work. That should not work. I have no idea why that worked, but I'm going to pretend like it didn't happen because I don't want to have to deal with that right now. If you want math notation, go into math mode. Now, let me address something that Larry asked over in the chat. If you look at a lot of source code, you will see the following. When Don Knuth invented the tech typesetting language, he used $signs to denote math mode. And he said he chose those symbols because typesetting mathematics is expensive in terms of computational resources. So he chose $signs for that. And here's why the LaTeX developers say not to use it. First of all, it produces exactly the same result. Okay, and when you look at that PDF file, you don't know whether I use $signs or the escaped parentheses. But here's what the LaTeX developers tell us. The $signs are not LaTeX syntax, they are tech syntax. And if you're using certain types of regular expressions to search for mathematical tidbits in your document, these $signs can confuse your regex engine, and they just generally don't recommend using the $signs. So about 10 years ago, I reprogrammed myself to use the escaped parentheses. So I'll be honest, I don't even think in terms of $signs anymore. I think in terms of this, and this is what I show students. I never show students the $signs. However, there's always one person in every class who goes out searching on, this was before ChatGPT, they'll go out searching for the LaTeX code that they need, and it will invariably come back with a bunch of $signs. And I say, where did you find the $signs? What do those mean? Well, I don't know. It's just what I found. I said, aha, you just admitted to plagiarism here. The LaTeX developers and the LaTeX purists will say that we should use the escaped parentheses. So I don't use this syntax anymore, and I don't teach this syntax anymore. Some of the LaTeX developers are very vociferous about these conventions. Others couldn't care less. I tend to agree with a lot of them. So like I said, about 10 years ago, I started using the parentheses for inline notation. Now, there is another type of math notation. It's called display math. Now watch this. You use square brackets. And I like to open these up like this. let's do a squared plus b squared equals c squared. Now, when you typeset this, it's going to do two things. First of all, it's going to center it horizontally on the page. And second, it's going to put the typographically appropriate amount of space before and after the preceding and following paragraphs. Yes, those are backslash square braces, Chris.
Thanks. It's hard to see the color
Yeah, I've got a strange color thing going
Yeah,
on.
I'm really having a hard time seeing what you're putting up.
Okay,
I try to
okay.
replicate it, it's wrong, and then it's very frustrating not to be able to see what the code is. And just
Okay.
saying,
okay.
they're one step behind. Our typing is a
Okay.
step behind what you're saying.
Let me try this. Let me just try some new fonts here. There's some new themes. You tell me what looks good for you.
That one's better.
You like that one?
Well, it's that when it's the darker, but when it's lighter against the light background, it's hard to see, but this is okay.
You can configure all of this over here. I can do, let's see, that.
Go for something with high contrast, I would say.
That's, yeah, the names of these things are not, let's see, how about, nope, darn it. That's not any better. GitHub, that's not. These all seem to have sort of a cloudy like appearance to them. Let's see. What about that? How about that?
That's better.
Okay.
Or maybe make the font a little, one size bigger. I know you already made it bigger
Make
once.
the font bigger. Okay.
I think that might help too. Yeah, that's much better. Thank
Okay.
you.
I can make it 2 notches bigger. That's at 20 point. I can make it 22 and 24. Oh, now I see why it was cloudy. That was the shading by the menu there. There's high contrast right there.
Okay, that's much better. Thank you.
So here you see display math sandwiched between 2 paragraphs. And I used to put spaces around my display environments like this. And I was told that that is bad because that inserts extra space around the equation. You have to look very carefully to detect that extra space in the PDF file. If you didn't know it was there, you wouldn't know it was there, which is kind of a fractal type of statement. But the style in LaTeX is to not put white space before or after your environment, your display math environment there. Now, the good thing about mathematics is that it works pretty much the way you would expect it to. If you want the name of a Greek letter, you simply type a backslash and then the name of that Greek letter. So if you want a zeta, you would say backslash zeta. It's pretty logical. There is one thing that you need to be aware of, though. And so I see a lot of this with trig functions. Okay, so let's say you want trig functions. So let's go into math mode here and let's do sine, cosine. Let's do sine alpha. Let's do cosine alpha. And what's the other one? Tan. alpha. Now, if you typeset this, yuck. Now, here's what's going on here. In math mode, LaTeX treats every character as the name of a variable. So it's saying, oh, this person wants S times I times N times alpha times C times O times S times alpha times T times A times N times alpha. That is not what we wanted, is it? I hope not. So what we want instead is backslash sign, backslash costs, and backslash tan, because those are defined mathematical, they're mathematical operators, actually. And LaTeX knows to typeset them not as multiplied variables, but as sine, cosine, and tangent. So you have to backslash those to get them to look like they're going to look in our math and physics textbooks. And I can always tell just by looking at, let me take the backslash off of the sign there. If I look at someone's document and I see sine, cosine, and tangent in italics, this is one of the rare cases when I can tell the code that they use. They did not use backslash sign. And I'm saying, oh, so why are you multiplying S times I times N times alpha? And of course, the student will look at me, what are you talking about? You've got to use backslash to escape those trig commands there. What about f of x? Okay. I'm going to go into display mode here for demonstrating these things. If you want f of x, you simply say f of x like that. Ta-da. How would you make a matrix? Okay. By default, LaTeX doesn't know how to make a matrix. In order to tell LaTeX how to make a matrix easily, you have to load an extra package. There's a package called AMS Math, and you have to load that package in your document. So you would have to say use package AMS Math. And the AMS Math command, the AMS Math package contains commands for using a matrix. Now, I don't remember that off the top of my head. If you want me to show you, I can show you. Let me just pull up the documentation for AMS Math here, because there's more than one command for doing it. Let me see here. Now, in just a second, I'm looking for the okay. Okay, here we go. So the command for doing a matrix, it depends on the size of the matrix that you want to make, Floyd. You can do what's called a big matrix. You can do a small matrix. You can also change the delimiter. You can use square brackets, or you can use parentheses. So let me just let me see if I can pull one up here. And I see your question, Larry. I'll answer that in just a second. Let's do a matrix here for Floyd. You would say begin. let's do P matrix. I remember every begin must have an end. Okay, now inside the environment, Lloyd, you simply enter, I'll use letters for this. You simply say A, and then you use an ampersand to denote the entries, and then you end each line in the matrix with a double backslash like that. And let me compile that. That should work. Let's see if it does. And there's your matrix. The P stands for parentheses. If you want square braces, you would change the P to a B. And this will give you square brackets around your matrix. Now, LaTeX isn't actually doing any math here, so it doesn't care that this is not a square matrix. It's simply typesetting the symbols that you're feeding it. So that's the quick answer on how to do matrices. And there are all sorts of variations for this. And every variation you can think of can be accommodated here. Okay, so Larry says when you put parentheses around your trig variable, why does that not look right? And the reason is because we're not supposed to do it that way. When you have one argument to the trig function, the policy is you really shouldn't use the parentheses like that. Some authors do it. Typographically, it doesn't really make any sense to do it. The one case when you would need it would be like if you were going to say sine of kx minus omega t. The parentheses are absolutely essential there, and it looks a little nicer. It has to do with how the delimiters are spaced. All of these, this is all described in the book that Knuth wrote back in the 1980s to document all of this. And oh, I misspelled omega. Apologies. Let me fix that. When it's in math mode, it detects that you're in math mode and that you're typesetting these characters as variables, and it assumes that there's a certain amount of space that must be on either side of the delimiter. And for a single thing in the parentheses, it looks funny to us. So it's a typographic convention. What about max x? You mean like as in the max, a function to pick out the maximum? Is that what you mean by that? Okay. There may be a package that defines that command. Otherwise, you have to do it yourself. It can be done. And I had not intended to show people how to define their own commands today. I'll simply say that that is something that can easily be accommodated for. And if you hang around after the workshop, I'll show you how to do that. There is probably a package out there that defines that command. I don't know off the top of my head what it is, but there is a way to define a sequence of letters as a math operator. So that can be very, very, very easily done. If you hang around after the workshop, I'll show you how to do that. So let's see, when do you start with a text editor and then copy and paste into Overleaf? And when do you just start out in Overleaf? Okay, that's a good question. I don't like to copy and paste from one source into another because, and this turned out to be a huge problem with GlowScript. Sometimes you would pick up an invisible line ending character that one or the other editor could not see, and it would break your code. So I strongly don't recommend cutting and pasting between editors. If you, the best thing to do is to save your file and then import your file, upload your file to Overleaf, for example. Does that make sense? I have a feeling I butchered the language there. Okay. Did that answer your question, Eric? Okay. You can pick up these invisible control characters sometimes, and sometimes the line ending characters can be different, and sometimes that can break the code. And invisible characters are very difficult to debug. Okay, so Nancy asks about subscripts on components. Okay, this is cool. It's almost trivial. So let's suppose I have a momentum vector, and I want to write this in terms of its components. Now watch how I do this. Whoops. See if you can predict what this is going to do.
If you want to indicate subscripts, you just put an underline, that what it is. That's pretty simple. Thank you.
Now, there is a catch. The catch is that the caret and the underscore will only recognize the first following character as a subscript or superscript. If you want more than one character, you must enclose the super or subscript in curly braces. Now, the LaTeX purist will say that even for one character, thou shalt use curly braces. I am in the process of retraining myself to do that. Because if you put curly, that means up here, I really should have put curly braces around that too in Dr. Einstein's equation. Now, I admit that I have been slack about this over the years. This is a new one for me, so I'm having to retrain myself to do this when I'm writing. And you might think, well, gee, doesn't this introduce a lot of extra typing? Well, not if you're a fast typist, or excuse me, keyboardist, or you can actually train your smarter editors to do this for you. Capital Greek letters are deceptively simple. You simply capitalize the first letter in the name of the Greek letter. However, many uppercase Greek letters are identical in form to their Roman letters, and they are not defined. So for example, do an uppercase alpha and see what happens. Let me do an uppercase alpha here. Okay, and you can see that didn't do anything because an uppercase alpha isn't defined. It's an undefined control sequence. Okay, it means that command is not defined. LaTeX says, I don't know that command. An uppercase alpha is just a Roman A when you need one. Why did they do that? Why did they do, you mean, why did they not define the uppercase Greeks? Because for some of them, well, for some of them, you can do that. For example, do an uppercase theta. We'll do an uppercase and a lowercase theta. Those are typographically distinct symbols. But typographically, an uppercase alpha is the same as what we call an uppercase A. So this all has to do with the fact that a lot of this was invented back in the 70s and 80s when memory was extremely tight. It may have taken 15 minutes to compile a document back in those days. Think about that. 15 minutes to compile one simple document. A thesis, an hour or more. Computers were very limited, and so they did everything that they can to make very efficient use of memory. And you're right, Floyd. They're requiring that you know that, and I agree that the average person is probably not going to know that. I completely agree with you. I completely agree with you. However, there's a way around it. And I'm not prepared to show it to you today because it gets into changing the fonts and everything. But I will show you that there is a package that you can load called Unicode Math that does define all of those missing Greek letters. For example, there is no Omicron defined in raw LaTeX, and we are using raw LaTeX. There is no Omicron defined. It is typographically identical to a lowercase Roman O. And the logic there is, well, they look so close, we don't want to waste the memory. You got to understand, 32K was considered a lot of that was considered a lot of memory back in those days. So nowadays, if tech were to be written from scratch nowadays, these deficiencies would not exist because we have the computing power to handle these things. But computers were very limited back then. And yep, the vet command is how you get the little arrow. What if you don't like arrows? You can say Math BF, which will get you the nice boldface notation. And students loved this. They loved being able to do away with the arrows. Arrows were used for vector notation only for writing on a chalkboard. You don't really find them in the physics literature other than that. So let's see, is there anything else here that I wanted to show you? Oh, let me show you how to do fractions. Okay, there is a frac command where you give it the numerator and the denominator, and it does exactly what you think it will do. What if you want to raise a number to a negative power? So what if instead of c squared, you want c to the negative squared? What do you have to do? I'll give you a hint. I already told you the answer. Got to use curly braces and put the -2 inside because it's more than one character, and that will typeset that as c to the -2th power. I want to show you one last thing, and this will basically end the stuff that I had prepared to show you. What if I told you that LaTeX can do floating point computation? Watch. Now watch what happens when I compile this. Holy cow. This thing just computed pi in double precision. What if you only want, say, 3 digits? What do you have to do? LaTeX can now do numbers. This has been an add-on functionality for a number of years. It's only been within the last couple of years that it has done it by default with no extra packages. All the standard math commands are built in. So for example, I can do, I can say 15 times cosine pi over 3. Boom. If you want pi to infinite precision, good luck. Oh, and by the way, I have an error in this line. I need a parenthesis right there. Okay. Okay, there we go. So pretty much anything that an introductory physics student would need to do on a calculator can now be done in LaTeX. I'm going to wait until a future workshop to go into this to show you how you would go about implementing this in a physics class. But LaTeX can now deprecate our students' computers, calculators from day one. No more calculators. How would you do the last line symbolically? Oh, you mean how would you actually display? Okay, so what you would do is this. You would say 15 cosine backslash pi over, you could either say pi over 3 like this, and you would say approximately equal to, or I personally, stylistically, would do a frac inside there, and I would say pi over 3. Now, this brings up an important point. I'm glad you asked that. Typesetting numbers and computing with numbers, where did I get pi over c, are different things, okay? So the key to make it, and notice that the parentheses don't match there. The way you fix that is you put a left in front of that left parenthesis, and you put a backslash right in front of that right parenthesis, and that will fix the sizing of the delimiters there. Typesetting a number is not the same as calculating with those numbers. And yes, there is floating point rounding error in this library. So you have to be, it's just like any handheld calculator, you have to be very careful. You have to be very careful because you don't want to lead students astray with it. So yep, that's a caveat. So the thing here that forces the numerical evaluation is this FP eval command. Okay, because LaTeX doesn't know that backslash pi is 3.141. It's just the Greek letter pi. That's all LaTeX knows about it. But over here, inside the floating point evaluation command, it knows there's a predefined variable called pi, and Euler's constant is also defined. And incidentally, it's smart enough to do trig functions with degrees. In other words, if I want to use 60 degrees instead of pi over 3 radians, I simply add a d onto the end of my cosine over here inside the floating point evaluation function, and it will do the calculation correctly. It's very flexible. It's very, very flexible. And I have an entire workshop devoted to doing floating point calculations inside a physics class. In other words, having students write up their homework solutions and now using this to do the numerical part. John, it used to be a separate package called XFP. Now it is built into the kernel. So I don't need the AMS math to do this. The only reason I added AMS math package up here is for the B matrix command to work. If I comment out this block of code here, whoops, sorry about that. That's what I get for trying to use the keyboard command. I'll just manually comment them out. And now I can comment out AMS math, and the floating point stuff will be the same. The matrix is going to go away. This is built into the LaTeX kernel. This happens by default. They built this into the kernel about 3 years ago, I think. By the way, the kernel is updated twice a year, once in March and once in June and once in November. So I'm not kidding when I say this is all under active development. Now, this concludes everything that I had planned to show you. And what I would like to do now is show you some resources and give you some time to do an evaluation for the workshop. Let me just pull up another browser here. Let me get out of this. And I have some web pages bookmarked in another browser, and I'm going to pull those up. Okay, so first of all, your first source of information for LaTeX, and this is both a good thing and a bad thing, is going to be LaTeX Stack Exchange. Now, Stack Exchange is known for sometimes having a culture of toxicity. And it exists pretty much everywhere. I will not say that it's entirely 100% friendly to newbies and beginners. They're very particular about how they want you to ask questions, but the odds are that if you have a question, somebody before you has probably asked that same question, and it has probably been answered on the Tech Stack Exchange. I'm an active member here, so should you decide to post there and I recognize your name, I will jump in and try my best to answer your question, okay? But this is probably the best single resource on the planet, but you've got to beware that it is its own culture and it can be off-putting to beginners. If you want to practice LaTeX, I can recommend 3 very friendly sources. There is a tutorial website called learnlatex.org. And it covers a lot of the things that we covered today. It takes a different approach. It's not, the audience is not assumed to be physics teachers. It's just assumed to be pretty much anybody. There are businesses out there, for example, that use LaTeX for all of their internal document creation and communication. So, and this was actually developed by Joseph Wright, who's one of the LaTeX developers. And it's a very robust and very helpful website. There are interactive examples here, and it's very well done. If you want to experiment with code, you can go to techlive.net. This is actually a server with a JavaScript front end that will let you write your code. Like, for example, you can enter enter hello world, and you can update this, and it will typeset for you, and it will serve you up a PDF file. This is not meant for entire documents, so don't do your thesis on this, because it will block you if it senses so many connections per hour. But this again was created by Dave Carlisle. He's one of the main LaTeX developers. It's a place to experiment with your code. It has the advantage over Overleaf that it is 100% up to date with all the new packages and all the latest versions of everything. And I think you can download your PDF file. Yeah, this is a full LaTeX, a full PDF. It's pdf.js. It's the same PDF library that Firefox uses. So you can generate your document. You can click right there and you can download it. Or you can delete your output and you can start over. So this is a handy little resource for practicing. There's also a beautiful place called the Island of Tech, which again is another collection of resources. These are more technical. These are more tech oriented. They're probably oriented more towards the Linux type users. This was created by Paulo Sereda, who was supposed to be here today. He is a tech developer in Brazil, and he created this website. One of the most valuable parts of the Island of Tech is TechDoc Online. One of the disadvantages of Overleaf is that you can't pull up any official LaTeX documentation. If you install LaTeX on your own computer, you can pull up the documentation for the AMS math package, for example. But Overleaf can't pull that information up. So you can go here and you can type in, for example, AMS math, and you could submit that, and you could pull up the English version of the documentation for the AMS math package. One thing I have noticed is that the documentation here is not always completely up to date. That should not be a huge deal for the basic stuff that we've talked about today. And honestly, read the documentation. I know that people don't like to do that, but all of this software was created by volunteers. LaTeX and Tech are open source. No one charges money for it. It's all open source. And we do, those of us who create these packages and software, the package, the documentation for my package is 100 pages. But it covers just about every question that you could possibly ask about that package. Lots of effort has gone into this documentation, and ultimately this is the best source. The problem is there's no way to put all of this in one big place. However, hot off the presses this year, and if you look up at my picture here, you'll see it. Here you go. This is the brand new LaTeX Companion 3rd edition. It's published in 2 volumes, 1,900 pages.
Can you stop screen sharing maybe? And
oh, I'm
we can
sorry.
see it better?
How about that?
Awesome.
Okay. $115 for both volumes. Don't go out and buy this, because I don't expect anybody to read 2,000 pages. Most of this documentation is to be used as on a read as needed. Like, for example, if you're using the AMS package, go to the documentation for the AMS package. You don't need this 2,000 page book just for the AMS package documentation. But this is literally hot off the presses. This was just published last month, and this is going to be the Bible for the next couple of decades. That is the original documentation for LaTeX itself. I have the 1994 edition, and things have changed a lot. Like there's no mention of floating point computation in here. All of the basic text and math commands that I showed you today are in here. Okay, but there's no mention of floating point computation in here. There's no mention of Unicode, because Unicode had not been invented at that time. But This is the definitive LaTeX document right here. URLs, absolutely. I will tell you that it is my intention that by the time the Sacramento meeting comes along, I will have a companion website, for this workshop series that has all of these URLs. So let me just put all of these URLs into the chat box over here, and you can grab them that way. And I'll just paste them in there one step at a time. I hope that I have convinced you that LaTeX is not insurmountable to learn. We have only covered the very, 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 very basics, and that's what I intended to do today. I wanted to get people comfortable with using the Overleaf editor and doing very simple things with text and very simple things with inline and display mode mathematics. Feel free to experiment. The worst thing you can do is get an error message and your document not compile. One thing that Overleaf does is there's code that's running in the background that parses the error log and tries to pull out the most relevant parts of the error message, and it does try to translate them to plain English. I think it was either I can't remember if it was Nancy or Rumi was able to look at the message and say, oh, I misspelled such and such a thing, and figure out exactly what was going on there. That is an advantage to using Overleaf, because otherwise you have to do that manually. You have to look at that log file to see what your error was. And it's sometimes difficult to do. It's always difficult to do. That's probably the single most frustrating part of learning LaTeX, is how to debug your errors. Yes, there are, Floyd, and I want to do a separate workshop on local installations. If you're on a Mac, you're going to want to get MacTech, which is basically a Mac-specific version of Tech Live. Let me put, I can't believe of all those resources, I didn't give you the Tech Live thing. Hang on just a second. Let me pull up that URL. Tech Live is the formal name for the distribution that is released every year. It is available for every platform. And every platform, I mean Linux, Mac, and Windows. The Mac specific version has a nice GUI installer and comes with Tech Shop and a lot of nice Mac GUI tools. On the other platforms, it's up to you to choose an editor. Lots of people use Emacs. I tried learning Emacs back in the 90s, and I simply could not get the hang of it. But there are just hundreds and hundreds and hundreds of editing environments out there. I really like Tech Shop, but it only runs on a Mac. You can use Windows Notepad to edit your documents, but you would have to compile them from a command line. And Windows and Mac users tend not to like command lines, but still the most efficient way to do it. But there are lots of editors out there. So I'm hoping that I can do a subsequent workshop showing how to set this up on your own local machine. The problem is I don't have a Windows machine anymore. I would have to research how to go about doing that. There is another distribution called MikTek. I'll type its name over here in the chat. I used it for years on Windows. It is now available on the Mac. It is not available for Linux. MikTek is, I used to use WinEDT. That was my editor of choice back in the day. And I had that thing tricked out. Oh my gosh. That was one of the very first shareware programs I actually decided to pay money for. It was that good. It's still around. It's still in development. And if I were still using Windows, that would be the editor that I would use, to be honest with you. It's got a built-in previewer and everything. If you're on Windows, I highly recommend it. Support the author. That's one man and his wife who developed that product. And I forget where they live. They were in Europe. I forget what country they were in. But yeah, that's a very highly respected editor. And you get an integrated environment as well for development. I think that's the end of what I wanted to do, Chris.
Thank you. And just another reminder to please do the evaluation. It really helps us and make sure that we can continue to get funding. But thank you, Joe. That was wonderful. I'll stop recording now. If anyone wants to stick around and ask questions, I'm sure that won't be a problem.
If you come to Sacramento, I'll bring some